Hello and welcome to a new lecture of classical motion of a single particle. So, I already discussed about central forces a little bit, mostly in the framework of Newton's laws and how you can have some conclusion about the nature of central forces. And if you remember that a central force is defined by its special properties, that a force whose magnitude depends on the distance from a point which is called the origin of the force to the point on which the force is actually acting. I can take another color over here, yes, sorry, yeah, this, and the force is acting along the line joining these 2 points. So, I can call this point as origin O and this point P as the target point. Okay. So, r cap can be actually this f r can be actually positive or negative according as this force is actually acting in this direction or in this direction. If f r is negative, that means that f is actually acting towards negative r cap direction. So, I would say that means P is getting attracted towards O. So, that is why I would say the force is attractive if f r is less than 0. If f r is positive, then that means f is actually acting towards towards P from O to P, that means this is repulsive in nature. So, repulsive if f r is greater than 0. This condition we will always use throughout our discussion. Okay. So, if you remember, the first conclusion we drew about this central force is that central force is irrotational. That means curl of f that we have calculated explicitly is equal to a null vector 0. Okay. And what was the immediate conclusion? That f can be written as a gradient of a scalar potential function, and the meaning is that f is conservative. That means half m v square plus phi is constant for the particle, okay, which is moving under this force. Okay. Second point, we also said that since f is having this property, f is always acting along r cap, whether it is positive or negative, that is not really mattering here, but if it is just parallel to r cap, then r cross f is another null vector, which means that the torque on the particle vanishes, and this means that the total angular momentum is conserved. Now, angular momentum is what? Angular momentum is r cross mv. I can call that L, capital L. This is conserved vectorially. Now, vectorially conserved means direction is constant in time, magnitude is constant in times separately. Okay? Magnitude is constant in time. So, I can now say that L is a constant if this is also constant and this is also constant. They are separately constants. Now, you see, if I can now think of a situation where I have a constant vector. So, let me just give you an example. So, let us say this is a constant vector. So, this basically gives you a constant direction in space, and also whatever be the motion of the particle with time, the direction and the magnitude of this vector does not change. Now, if we do something very simple but interesting, I take a dot product of this L vector with r here. R is the position vector of the particle, that is the OP vector. Okay. If you remember, so r is actually here OP vector. Okay. Then what will be that? R dot r cross mv. Okay. Again, if two vectors of a scalar triple product, they are identical, then it is 0. Okay. That means that R and L, they are orthogonal to each other, they are perpendicular to each other, and none of R and L are in general 0. Okay. So, what will be then the possible scenario for the motion of the particle? This is a constant vector and it does not change its magnitude and direction in time, and then I am now considering that the position vector, okay, of a particle is always in such a direction which is 90 degree or perpendicular to this vector, whatever be the position vector. That is exactly what I just showed. Okay. So, it can be in this direction, it can be in this direction, it can be in this direction, but it cannot be in this direction. So, you see, in a sense, if we resume that, what is the conclusion? That the position vectors can always lie, I mean the position vectors should always lie in a plane which is perpendicular to this constant vector L. Okay. So, that is why I have to say the immediate conclusion from that is, since L or L cap is constant, R needs to be confined in a plane perpendicular to R, to L. Okay. And that means that the motion must take place in a plane, in a 2D plane actually. Okay. And that plane is not an arbitrary plane, a plane perpendicular to L cap, okay, or L, or I mean L vector itself. Okay. Now, you see, once I conclude about this 2D nature of motion under central force, many things are actually simplified. Okay. The first immediate thing you can easily see that instead of 3 variables, instead of 3 space coordinates, you just need 2 space coordinates to designate the position of the particle. Similarly, you will now also have 2 components of velocity, 2 components of acceleration or force, whatever. Okay. So, you see the complexity of the system actually reduces substantially. Okay. Then we will do something much more also interesting. We will also say that, okay, we now know that Newton's law already said that m d2r dt2 is equal to f, and here for our case f is fr r cap, and since we simply know that this is the total acceleration vector, I can actually know from my knowledge of this 2D motion under a central force, this acceleration will be actually also will be actually in a 2D plane, you can see. So, I can actually write the whole acceleration as a r r cap plus a theta theta cap. Okay. Now, one can at this point ask me that, is this true? Can I derive that? I mean, I can understand that r can be always in a plane, but does it say that the dynamics is also taking place in a single plane? Okay. For that, I will just do some calculations which is also useful for all the students to understand general concept of curvilinear coordinate systems. Okay. So, what I will do is I will first try to say that what is the nature in of this position vector and the velocity vector and the acceleration vector in spherical polar coordinates, or actually for our case it is a plane polar coordinate system. Okay. Let me just write like that. So, r vector you can in now I just go to 2D, in 2D, that means I have plane polar coordinate, plane polar coordinates. I know that in this system I have always this r vector as r times r cap. So, this is the definition of r vector. Now, since this is plane polar coordinates, I know the only variables, meaningful variables are r and theta. Okay. So, if any vector should change, then they should actually change due to these two coordinates r and theta. Okay. Now, I will just try to calculate the velocity vector from that and the acceleration vector from that in this system. So, what will be then r dot, r vector dot. So, this is actually the velocity vector. So, remember here I would like to make a caution here, a point of caution, that is sometimes you just mix up or confuse with r dot and r vector dot. So, they are actually different. I mean, I am coming to this point in a while. Okay. So, this is the r vector and ddt of that r vector. So, this is nothing but, once again for your understanding, this is ddt of r vector as a whole. Okay. This is the velocity vector. Now, what is that r vector? This is r times r cap. Okay. Now, r cap is the, so r is the position vector of p, okay, at any time instant t, okay, and r cap is the unit vector, I mean connecting the origin and the target. That means O, I mean a unit vector acting along OP. Okay, if you remember this figure over here. Okay. So, now I will write this is equal to dr dt r cap plus r dr cap dt. Here you see this is a mammoth difference between plane polar coordinates and the Cartesian coordinate system. So, that is why I keep this part of the screen here blank, so that I can discuss the difference between these two coordinate systems. In Cartesian systems you have three directions, let us say x, y and z, a right handed Cartesian system, okay, and the three directions are represented by x cap, y cap and z cap. But if you just change time, they will not change in time. That is why x cap dot, y cap dot and z cap dot all are 0, okay, or null vector. But what happens in a in a plane polar coordinate system? Let us say in a plane polar coordinate system, I mean you can also think this in case of a spherical polar coordinate system. I am just for this lecture I am staying a little bit simpler, and I just say okay, I have to just do this 2D plane polar coordinate. In 2D you have actually x and y and you have r and theta. So, this will be this r vector for p, okay. So, this is y cap, this is x cap, they are the Cartesian unit vectors, and now for this one you know the r unit vector is along this direction and the theta unit vector is the direction in which theta is changing. So, theta is this angle, polar angle theta, okay, which is the angle made by this line with this radius or this position vector with x axis, and the direction theta cap is defined by the direction of the change of theta, and which is actually perpendicular to r cap and given by this direction, which is should be like this. Okay. So, this is the direction of theta cap. Now, you see if the particle with time is travelling from here to here, then of course, in the new position the particle will have a new r cap direction and a new theta cap direction. So, you see I can call this r cap prime and theta cap prime. Okay. So, you see unlike this Cartesian system in plane polar coordinate, and actually this is also true for cylindrical systems, spherical polar coordinate systems, the unit vectors, they are not constant in times. Okay. But of course, in cylindrical polar system you will see one, that is the direction z, which is the direction of the axis of the cylinder. This behaves like Cartesian z axis, and that is why z cap dot does not change with time. Okay. But whenever there is a spherical polar or plane polar, anything which is sphere, the direction of the unit vectors actually depends on where exactly the particle is situated, and that is why with time they also changes, and that is why r cap dot theta cap dot, they are not 0. That is the first thing we have to understand. Now, what they will be? For that, so there is a very easy way to do for this one. I know that in general r vector in plane polar coordinate is nothing but r cos theta. From this one you can just draw this. What is x? X is this r cos theta, and this y is r sin theta. So, you can say r cos theta x cap plus r sin theta y cap. Then what is r cap? R cap is nothing but this by modulus of r. Modulus of r is nothing but r scalar itself, this one, and that is why the unit vector will be simply cos theta x cap plus sin theta y cap. Okay. Now, what is dr cap dt? So, I now have to take the ddt of this expression. So, dr cap dt will actually be something. So, you have to write ddt of cos theta x cap plus sin theta y cap, which is nothing but dd theta of this thing cos theta x cap plus sin theta y cap. Because you see here, okay, this is a function of theta and theta is a function of t. So, I can write this, and I can finally multiply this as some, I just say in a proper way, multiply it d theta dt. So, that finally it gives me ddt of this ddt, I mean finally. So, this total expression is actually equivalent to this thing. Okay. I can write this d theta dt as theta dot, and what is d d theta of these things? This is nothing but minus sin theta x cap plus cos theta y cap. Okay. And what is this? I still do not know, because I even do not have any idea about theta cap, how to write that. So, for that I want to a little bit digress at this moment, and would like to talk a little bit more a general concept how in a curvilinear coordinate system without much problem you can calculate the unit vectors. Okay. So, for example, in 2D Cartesian coordinate system you have x and y. So, if I say x and y, what they are? They are two independent coordinates, and what are x cap and y cap? So, actually x cap and y cap, they are two unit directions, because x and y they are independent. It means that x cap and y cap actually are the directions in which the x and y coordinates can be changed independently of each other respectively. So, that means along x cap, it is only the x coordinate which can be changed without changing y, and along y cap. So, I just draw this so that you understand what this is actually. So, if this is a 2D Cartesian system, what is x cap direction? X cap direction is of course the direction along x axis, but once again how to actually define this? The proper way to define is that this is the direction along which if you just move, your y will never change, but your x will only change. So, this is nothing but, so if now you have for example, a position vector or something, anything like this, a position vector like this. So, this position vector you can actually, okay. So, so that position vector actually is the position of a particle, okay, and x cap is the direction along which the particle's x coordinate only changes without keeping y coordinate unchanged. And what is that? This is nothing but del r del x, because that is exactly the meaning of del r del x, that is del r del x, y is kept constant. Now, if we do that, what is the definition of r? R's definition is x I cap plus y j cap. What is del r del x then? This is simply, so del r del x is nothing but I cap. So, I can write, I just for instance want to write this x cap properly, and then I am coming to y cap. X cap is actually del r del x by modulus of del r del x. In case this is not a unit vector, since this is a unit vector, for an expression of this has to be divided by the modulus of this, okay. And since in this case you see the modulus of this is actually 1, then actually both of them are equal. So, that is, I mean, actually just writing this one or not writing this one, they have the same meaning, and you have x cap is equal to I cap, or simply, I mean, this is actually x cap as well, okay. Similarly, for y cap, you have del r del y, that means this is the direction along which only y can be changed, but keeping x constant, this, okay. And again you will see this is nothing but the z cap or just the y cap itself, the same thing. Now, this is not exactly so straightforward for, I mean the method is straightforward, but this is not exactly so trivial for spherical polar or plane polar coordinate system. For plane polar coordinate system, r cap is again the direction. Now, you see, you think of the situation, you have a plane polar coordinate system 0 x y, and so what is this direction? This is the r cap, we know this is the direction joining 0 to the, I mean the origin to the particle, but the position of the particle, okay. But what is the exact, I mean meaning of this? This is the direction along which if you just go, only r will change, but theta will remain unchanged, and this is the direction along which if you go, your r will be unchanged, but your theta will be changed. So, we can simply now write r cap is nothing but del r vector del r and modulus of del r vector del r. So, this is now, you see, this is cos theta I cap plus sin theta j cap, and the modulus of this is cos square theta plus sin square theta root. So, it is cos square theta plus sin square theta, and this will be actually 1, and that is why again you simply have cos theta I cap plus sin theta j cap. Now, you see, with this one you do not have to remember anything. So, theta cap is exactly del r del theta by the modulus of that vector. So, you can do everything directly. So, if you do that, if you do the derivative with respect to theta, it will give you, but keeping r constant, then it will give you of course minus r sin theta and this will be plus r cos theta. So, minus r sin theta I cap of course plus r cos theta j cap. Okay. And what will be the modulus of this? This will no longer be 1. The modulus of theta cap is actually theta, I mean the modulus of this vector is actually having a magnitude r. Okay. And that is why, so because this will be nothing but the modulus of this, which is r square sin square theta plus r square cos square theta, you take the square root, you will have r, and that is why theta cap is minus sin theta I cap plus cos theta j cap. You now see this one is your theta cap, minus sin theta I cap plus cos theta j cap. So, minus sin theta I cap plus cos theta j cap, okay, or x and y are synonymous to I cap and j cap, as I told in a previous lecture. Okay. So, what is this? This is nothing but theta cap. So, that is why d dt of r cap is nothing but theta dot theta cap. Okay. Now, you see you have something very interesting. So, I can actually write this thing as r dot. So, this is actually d dt of r modulus. So, r vector modulus, this is the scalar r. So, that is why this is written as r dot r cap plus r. Now, what is this? You have just seen this is theta dot theta cap. Okay. So, I can now identify this quantity as v r r cap plus v theta theta cap. So, this is the radial component of velocity vector, this is the cross radial or the theta component of the velocity vector. Okay. So, this is how the velocity vector in 2D plane polar coordinate should look like. Now, what about r double dot? Because in order to finally write Newton's law in plane polar coordinate system, we have to reach ar and a theta. So, what is r double dot? So, r double dot is again d dt of r dot vector. Now, d dt of, we now know this is r dot r cap plus r theta dot theta cap, and every one of them is a function of time. No one is not, I mean no one is necessarily constant. Okay. So, I just write simply using the chain rules r double dot r cap plus r dot r cap dot plus r dot theta cap plus r theta dot square theta cap plus r theta dot theta cap dot. Okay. Now, you see you have this, you know, because one is along r cap, one is along theta cap. This you also know, this will be along theta cap because this is r cap dot, this will be along theta cap, this is also you know, but you still do not know what is theta cap dot. So, theta cap you have just measured, sorry, theta cap is nothing but minus sin theta I cap plus cos theta j cap, and theta cap dot is equal to minus. So, you have to actually write. So, theta cap dot is nothing but d d theta cap d theta times d theta dt. Okay. So, there will be, so d theta dt is nothing but theta dot, and this one is now easy to understand, this is minus cos theta I cap minus sin theta j cap, and what is that? If you remember, this is nothing but minus theta dot r cap, because this is minus r cap, cos theta I plus sin theta j is r cap. So, this is minus r cap. Okay. So, I am just going to the previous one and I try to write things in a condensed way. So, you see r double dot, and here this one is nothing but, so there is a dot, this one is nothing but given by minus theta dot r cap. So, you have actually this whole thing as minus r theta dot square r cap. So, you will have minus r theta dot square r cap plus here you have all these things which will have the direction theta cap, because this is, so now you will have, so you know r cap dot is nothing but theta dot theta cap. So, it will be, so r dot theta cap. This is also r dot theta cap. So, we will have actually 2 r dot theta cap. I mean, I can write theta cap afterwards. And this one, if you also see carefully, this one is plus r theta dot square theta. Both, I mean, this is this, yeah, and then you write this is theta cap. Okay. So, you see that this is the case where you can see that this acceleration has two parts. So, what is this? This is the acceleration. It has two parts, one is along this direction, one is along theta cap direction. Okay. So, now if I just try to understand one thing, if I just take this expression 2 r dot theta dot plus r theta dot square. Okay. So, let me just take one thing. So, r dot theta dot this, yeah, I mean, I think I am sorry, I think there is a, yeah, there is an error. This is not theta dot square, this should simply be r theta double dot, because this will act, ddt is acting on theta dot. So, it will give you theta double dot, yes, okay. So, I will actually have r theta double dot, yeah. So, if I now just take this term, okay. So, what I will get? I just take this term separately, you see. So, I can now write my AR is equal to r double dot minus r theta dot square, and A theta to be equal to 2 r dot theta dot plus r theta double dot, 2 r dot theta dot plus r theta double dot. Okay. What can I do from this? So, if I take 2 by r, okay, I take 1 by r common. So, it will have r dot theta dot plus r square theta double dot. Just a careful observation you will gives you, this is nothing but 2 by r ddt of. So, if you just take this, I mean I'm again sorry because I have written wrong expression, I am sorry for that. This will be a 2 over here, because this is the case, right? Yeah. So, this is 2 r dot theta dot plus r theta double dot, yes. So, 2 will be here. So, that is why I will take here 1 and I will make 2 over here, yeah. So, finally, it is the same over here, yes. So, finally, you will have that ddt of r square theta dot, because if you just see what will be the ddt of r square, that will be 2 r dot, okay, and theta dot is just there, and then it will be r square ddt of theta dot, which will be theta double dot. So, this will be simply this. So, I can now just equate this thing to our knowledge of central force. I can say, okay, so since for a central force, since for a central force m r double dot minus r theta dot square r cap, I am just writing like this, plus 1 by r ddt of r square theta dot theta cap is equal to f r cap, then I have two immediate conclusion. Okay. One is m r double dot minus r theta dot square is equal to Fr. The second one is 1 by r d dt of r square theta dot is equal to 0, because in the direction of theta cap this is actually there is 0. Okay. So, if I do that, actually this gives me something interesting, that r square theta dot is constant. I can call that h. Now, my question to you is that, is this constant a new constant of motion, or this is something which we already know? Just a small calculation, you can easily see that if you do r cross mv, for this case r is nothing but r times r cap and cross m times. So, v you now know in 2D polar system is m r dot r cap plus r theta dot theta cap. So, what is the relation between, I mean what is the total expression? So, this one will vanish, this thing cross with this thing will vanish, because both of them are directed along r cap. These two will not vanish. So, you will have m r square theta dot and r cap cross theta cap. I can call that a unit vector which is perpendicular to the plane of motion, and that is z cap. And what is a constant unit vector? What is the unit vector? Perpendicular to the plane of motion under a central force. This is nothing but the unit vector along the angular momentum. So, you can easily say this is nothing but the L cap direction. Okay. So, I just write this is equal to m r square theta dot L cap, and this is L cap direction without any surprise, because this is L vector, and this one m r square theta dot, m is constant. So, it actually says r square theta dot is nothing but a constant, because angular momentum is a constant vector in a motion under central force. So, its magnitude is conserved. So, that is why r square theta dot is conserved. Okay. Now, what is the biggest conclusion and the surprise from this? If this r square theta dot is a constant, what you call now h, I can actually call that as modulus of L by m, or simply L by m, which is the angular momentum per unit mass. If you write like this, then how can you write theta dot? You can write theta dot also in terms of the constant h and r square. And why this is very, very good news for us? Because the equations of dynamics can now be written as m r double dot minus r theta dot square, you can simply write as h square by r to the power 4. So, h square by r to the power 4, okay, is equal to f of r. So, you see that it will finally become m r double dot minus h square by r cube is equal to f of r. Okay. So, already by the fact that the angular momentum is a constant vector and r dot angular momentum is 0, we have said that the motion takes place in a plane, and so the necessary variables which can be, necessary space coordinates which can be meaningful for defining any change in that plane will be simply expressed in will be simply given by r and theta variable. Now, you see, using the fact that the angular momentum has a constant magnitude which relates the theta dot to r square, actually finally reduces the equation of dynamics under a central force motion only in terms of the time derivatives of r and r. Okay. So, that is why finally you can see the whole equation of dynamics becomes effectively reduced to one space coordinate and its derivatives. Okay. And this is called motion which is effectively one dimensional. Of course, this is not a true one dimensional motion, this is a motion reduced to effectively one dimension, okay? And this is exactly the case of any central force, okay? Thank you.